So we've learned that we need a more sophisticated number, or two of them, that will measure the average amount of deviation from the mean from a data set. That's what standard deviation will measure, and variance too, because variance and standard deviation will go together, you'll see. But we first need to see where they come from. We need to understand them. Now, this is a one-time only deal. We're going to find this by hand once, so you can kind of see how this works and what these two values mean. So let's look at the statistics exam again. Here's a nice dot plot of the scores, and there they are in a table. Now, the deviation is the deviation from the mean. It's how far away you are from the mean. Now, remember, the mean was at, oh, we did it in green. I remember now. It was at 74. It's right here. Right? That was the mean. It was x bar, right? So x bar equals 74. So when you want deviation, what you're looking at is, hey, how far is every value away from the mean? So you take every value x, which is like 60 is an x, 100 is an x, 61 is an x, and so on, and you subtract them. Okay, so 60 take away 74, 100 take away 74, and so on. 61 take away 74, and so on. Okay, so this is negative 14, 26, negative 13, negative 9, 11, 16, negative 12, negative 10, 2, and 3. Right? I don't really need all those equal signs in there, I guess. I was just doing it for those top lines, but I don't really need them there. Okay, those are the deviations. How far you deviate from the mean. All right, lovely, beautiful. So what'll happen if I add them all up, right? Because when we think about average deviation, right, we should be able to take our deviations and add them all up and divide by how many there are. I mean, that's what we're looking for, right? All right, well, what happens? Let's grab a calculator, which, by the way, you could have grabbed if you wanted to, see any of those values. I just pressed clear to get out of that menu. But, 60 minus 74, oops, 60 minus 74, enter, and so on. All right, so what's negative 14? Ooh, I have to do this way. Make sure you type the little negative sign, not the subtraction sign. You're not subtracting. It's negative 14 plus 26 minus 13. Now I can use the subtraction signs. Minus 9 plus 11 plus 16 minus 12. 12, sorry. What happens is I'm typing on a computer, and so it sometimes is a little slow in catching on what I'm doing. There we go. And that first number had to be a little negative because it was in front, right? Whereas all the other ones can be subtractions. Oh, look at that. It's 0. Rats. All right, so this is 0. When we get the sum, it's 0. And that's actually talked about right down here. So let's go look at it. We want to find the average deviation, right? Because we want to know how far all these data points are from the mean. So why not just add the deviations and divide? Well, because when we add the deviations, it will always be 0. Now, why is it always 0? There's nothing special about this data or this particular data set. And it's because the mean was the balance point. That's what it means for the mean to be a balance point. That's the definition. It's that the aboves and the belows will all cancel each other out, right? Speaking of which, did you notice how some had positive deviation and some numbers had negative deviation? What was the difference? So if you look at the 100, for example, that's positive. If you look at 61, that's negative. Because positive deviation means the score is above the mean. And negative deviation means the score is below the mean. Right? And so what's happening is that they balance each other out. Because the mean is the balance point, the above the mean and below the mean, below the mean and above the mean, will balance each other out and will cancel out. Rats. All right, so then the question becomes, if this is going to happen every time, if it's always going to be 0, so this is always going to happen, right? Because mean is the balance point. Then what can we do to mathematically fix this? That's this question right here. What can we do to make it so that we don't have this problem? So the mathematical fix, there's two of them that you can use. To make it so that they don't cancel each other out, you can use absolute values, which leads to something called the absolute deviation, which is interesting in its own right, but not what we're going to work with. We are going to square the deviations, because if you remember from any math class you ever had, right, square, if you square a negative number, it turns it positive. For example, if I take negative 14 and I multiply it by negative 14, that's positive 196. Or in other words, if I put parentheses, negative 14, close parentheses, squared, right? That's what I'm doing, right? So then I need 26 squared. I need, well, I actually know the rest of these. So I can know the rest of these from my times tables in case you want to see them. Okay, so what we're going to do is we're going to take the deviation that we have and we're going to square it. So we're going to take x minus x bar, right? That's the deviation. How far are you from the mean? And we square it. So that turns this number into negative 14 squared, which is 196, right? This was 676. I didn't need 13 because I knew 13 from my times tables. It's 169, 81, 121, right? 256. So I wrote that weird. 144. 10 squared is 100. 4 and 9. Now we're getting somewhere. So now we can add up those numbers, and they're not going to make 0 because they're all positive. So if we take 196 plus 676 plus 169 plus 81 plus 121 and so on. Hopefully I typed it slow enough. We get a sum of 1756. Now remember, why am I writing those numbers down there? Because we have it down here that these are going to be the sums. That little symbol lets us know that this row down here is our sum values. All right, so we got the deviations, right? Because that makes sense. I mean, what we're looking for is average distance from the mean. The problem is we couldn't do average the way we're used to. We couldn't just add them up and divide. It wasn't working because when you add up, you always get 0. So what we're doing is we're going to square them, right? And when we square them and add them up, then we get 1756. Okay, well, why not square them like we did, 1756, and then divide, right? So that's what we will do, and that is called the population variance. So if you take that 1756, here, this is sigma squared. This is a definition. I can put it right here in a little box. Sigma squared is, now look at the definition, don't get freaked out. It's just saying add up the deviations squared, which we found, right? The sum of the deviations squared, and divide by how many there are. So sigma squared, when we added up our deviations, we got 1756. And you just divide it by 10, which I don't even need a calculator for. It moves the decimal. So it turns it into this. That's the population variance. That is what it is called. Now the units for it, well, we'll get into that. I'm just going to leave some space. I'll write the units later. Matter of fact, I'm going to put the population variance part down here instead of up there. So that way I have room to write the units. Sorry, I should have thought of that. So I'll just leave myself a little space and I'll be back to talk about units. Oh, I guess I'll be back right now. The units are what? So wait. These were points, right? These were points on an exam. So when we do this, if these are points, then these are points squared. No, I'm not kidding. That's what it really is, which is crazy, right? Points squared. right? So the units here are points squared, to which you say, huh? That's no good, right? Point squared, that doesn't mean anything. Exactly. Variance isn't used for that type of interpretation. So how do we get rid of the squaring? How do we make it so it's just regular points? And of course, keep in mind, it's not going to be points every problem. Like if it was dollars, it'd be dollars squared. If it's inches, then it's inches squared, right? That kind of thing. So the population standard deviation is sigma, which would be the square root of 1756 over 10. In other words, it's the square root of 175.6, which we would grab a calculator for. Square root is above the x squared button right there. So I hit second x squared 175.6, enter. And I get 13.251. That has points as its unit. That is the population standard deviation. You can think of it, standard is another word for average. It's the average deviation from the mean, right? How far everybody was from the mean. All right, but our data set was not a population. Our data set was a sample, not a population. So now what do we do? How do you accommodate for that? Well, what you do is instead of dividing by n, which was 10 in our case, you would divide by n minus 1, which in our particular example means we would divide by 9. Right? That turns it into a sample. I don't want to get too into the weeds about why that works, but it does. And I will tell you that that little n minus 1 is called degrees of freedom, and we'll talk more about that later. That actually has import for us in chapter 9. So degrees of freedom, see chapter 9. See chapter 9 when we get there. So when we get there, we'll come back to this and look at this page and go, oh yeah, right, that's what that was. All right, so this data set was a sample, not a population. So what we do is take the 1756, so let me do this, s squared. Instead of dividing it by 10, you divide by 10, take away 1. Now remember that division sign is a grouping symbol. So what you're doing is 1756 divided by 9. All right, so if I grab a calculator, calculator, 1756 divided by 9 gets me 195.111. Right? And that would be point squared still, right? It still has the wacky unit because that is the sample variance. Variance always has squared units, right? Because you squared things to make them positive. So variance is not as useful for interpretation, you can imagine, as standard deviation. Now, if that's the sample variance, then the sample standard deviation is the square root of that. So it's the square root of s squared, which means it's the square root of 195.1 repeating, which is, let me grab the calculator. So if I hit second square root, that little x squared button, so hit second x squared, and then I actually want the 195.1. So if I hit second and then the little negative sign, see what's above it? ANS means answer. So take that last answer. It'll take the last answer it found and take the square root of it. And I get 13.968. There we go. Now that would be points, right? It's not points squared. Oh, this one, that was supposed to be a 2 there. Sorry. So that's points squared like that. And that's points right there. This is the sample standard deviation, which we abbreviate a lot to S or STDEV because it's such a long phrase to write. Basically to say, hey, what's the average spread, right? The average spread is 13.968. So most data points are about 13.968 away from the mean.